For the differential equations, xy divided by dx is equals to x plus 2 into y plus 2. Find the solution curve passing through the point 1, minus 1. Okay, so x will be 1 and y will be minus 1. So we first find the general solution of the given differential equation xy divided by dx is equals to x plus 2 into y plus 2. So we re-evaluate the terms, that is we take y on one side, y's term on one side and x terms on one side, okay, and we integrate both the sides, okay. Now we have denominators y plus 2 and numerators y, so we take y plus 2 minus 2, okay, so we consider y plus 2 minus 2 and the denominator will be same as it was. And what we'll do here on the right hand side is we'll give the denominator separate to both the numerators, both the terms in the numerator, okay. So x upon x plus 2 upon x, so x upon x is 1, so 1 plus 2 upon x, okay. So now here again we'll give y plus 2 to both the terms in the numerator, so y plus 2 upon y plus 2 minus 2 upon y plus 2, so y plus 2 upon y plus 2 will be 1, so 1 minus 2 upon y plus 2 dy is equals to 1 plus 2 upon x dx, okay. So integration of 1 will be y, integration of 2 upon y plus 2 will be 2 log y plus 2 is equals to integration of 1 will be x and integration of 1 dx will be x and integration of 2 upon x dx will be 2 log x plus c, okay. Since the curve is passing through x comma y, 1 comma minus 1, y will be minus 1 and x will be 1, putting the values of y and x, we will get c is equals to minus 2. Putting the values of c, y minus 2 log y plus 2 plus x plus 2 log x plus minus 2. So we'll consider this minus 2. Okay. So y minus x. So we'll shift the x term on the left hand side, y minus x plus 2. Shifting this to the left hand side as well is equals to 2 log x into y plus 2. Okay. Shifting this term to the right hand side. Okay, so 2 log x plus 2 log y plus 2, so it will be 2 log x into y plus 2.